Mwalimu Theophil Academy reminds you that success is not an overnight process, but consistency. Welcome for today's session.
What is electrochemical equivalent of a substance? Simply we say that the electrochemical equivalent, which is denoted as Z of a substance, is the mass of the substance discharged when 1 coulomb of electricity is passed through an electrolyte. So, whenever you're told about an electrochemical equivalent of a substance, you have to take note that it is the mass of a substance discharged during electrolysis when 1 coulomb of electricity is passed through an electrolyte. Now, after this definition of electrochemical equivalent, let us see its unit. Electrochemical equivalent is expressed as gram per coulomb. As we've said that it is the mass liberated when 1 coulomb of electricity is passed through an electrolyte. Note, electrochemical equivalent of a substance is given by the formula. Electrochemical equivalent is calculated by using this formula. It is the relative atomic mass over valence of an element concerned times Faraday's constant. What are these stands for? Let us see. Z in this formula stands for electrochemical equivalent of a substance, as usual, as we have seen in the previous explanation. RAM stands for relative atomic mass of a substance whose ion is discharged. V stands for the valence of an element whose ion is discharged. And F stands for Faraday's constant. And this Faraday's constant is equal to 96,500 coulombs, as you can see. So, whenever you're asked to calculate the electrochemical equivalent of a substance, you have to take note that it is the relative atomic mass over the product of valence and Faraday's constant. Now, we have introduced a new term, which is Faraday's constant. What is Faraday's constant? Simply we say that Faraday's constant is the amount of electric charge carried by 1 mole of electrons. So, the amount of electric charge carried by 1 mole of an electron is what we call the Faraday's constant. You have to note that 1 Faraday is the quantity of electric charge carried by 1 mole of electrons. That is to say, 1 mole of electron is equivalent to 1 Faraday and is equal to 96,500 coulombs. You have to note this relation, that 1 mole of electron is equivalent to 1 Faraday, and 1 Faraday is equal to 96,500 coulombs. So, after this, let us see the way we can calculate different electrochemical equivalents of various elements. Here, we are required to calculate the electrochemical equivalent of copper. As we have said that the electrochemical equivalent is equal to the relative atomic mass of the element of the product of valence and the Faraday's constant. Now, for the copper, it is known that the relative atomic mass of 1 mole of copper is 63.5 grams. So this is divided by the product of its valence and Faraday's constant. The valence of copper is 2 times Faraday's constant, which is 96,500 coulomb. As we have said that 1 Faraday is equal to 96,500 coulombs. So here, what are we going to get? Now let us compute it by using a calculator. It is 63.5 over 2 times 96,500. You get 3. The answer is equal to 3.290 times 10 raised to -4. This is gram per coulomb. Gram per coulomb, as we have said that the unit for electrochemical equivalent is gram per coulomb, as I have written there. Now, this is the electrochemical equivalent of copper. This is the This is the electrochemical equivalent of copper. Let us see the electrochemical equivalent for oxygen. For oxygen here, the relative atomic mass of oxygen is 16. So we take 16 over its valence. The valence of oxygen is 2 times Faraday's constant, which is 96,500 coulomb. So here, when we compute in a calculator, we can compute it as follows: 16 over bracket 2 times 96,500. 500. The answer is 8.298.290 times 10 raised to negative 5 gram per coulomb. This is the electrochemical equivalent for oxygen. So whenever you are asked to find the electrochemical equivalent of oxygen, you have to know that it is 8.290 times 10 raised to negative 5 gram per coulomb. So this is the way we can find the electrochemical equivalent of any element concerned.